Assalamualaikum everyone. Welcome to my video tutorial for high school physics students. This episode focuses on calculating the period of oscillation of a car with worn out shock absorbers. How do we apply the concepts of simple harmonic motion in this situation? To find out, just hang on, watch and learn. The question is, four passengers with combined mass 250 kg compress the springs of a car with worn-out shock absorbers by 4.00 centimeters when they get in. Model the car and passengers as a single object on a single ideal spring. If the loaded car has a period of vibration of 1.92 seconds, what is the period of vibration of the empty car? We're given the total mass of the car occupants. This is labeled m sub p equal to 250 kilogram. So this mass corresponds to a force or gravitational force of 250 kilogram multiplied by 9.8 meter per second squared or 2,450 newtons. This is exactly the compressive force exerted by the car's occupants when they get into the car, compressing the spring of the shock absorber. Alright, so this is the picture of a typical shock absorber of a car. Alright, according to the question, this is already a worn out shock absorber. Alright, we're also given the change in the length delta x equal to negative 4.00 centimeters. Alright, the change in length has a negative sign. Alright, because when the force F is applied on the spring, alright, the new length of the spring is less than its original length. Alright, so when the car with the driver and the passengers aboard hits a bump and the car starts oscillating up and down in simple harmonic motion, the period of vibration, capital T prime, is also given, equal to 1.92 seconds. And we assume that the car and the occupants are a single object on a single ideal spring, meaning that the spring obeys Hooke's law. Our target variable is the period of oscillation of the car if the car is empty. Alright, so this period oscillation that we are going to look for is denoted here by capital T. That's our target variable. Starting off with our calculations, we first find the force constant K, or the spring constant, whose formula is just equal to negative F, alright, or the applied force divided by delta X, or the elongation, the spring. Alright, so substituting, we have negative 2,450 newtons divided by negative 0.0400 with three significant figures for delta X, that's in meters. Alright, so simplifying, we get the value for the force constant K equal to 6.13 raised to the fourth power kilogram per second squared in three significant figures. Alright, now we are given the period of oscillation, capital T prime, whose formula is 2 pi multiplied by the square root of capital M divided by K, where capital M is the total mass of the car and its occupants. Alright, so we can find the total mass capital M using this equation. Alright, we will isolate capital M and we will get its working equation. Capital M equal to the square of capital T prime times K divided by 4 pi squared. Alright, so substituting, we have 1.92, this is the given value of T prime, okay, square that, and then multiply it by the value of K, 6.13 raised to the fourth power kilogram per second squared. Alright, and then this will be divided by the value of 4 pi squared, which is 39.5. Doing our math, we will get the value for the total mass, capital M, equal to 6,720 kilogram in three significant figures. So with this as the total mass, we can find the mass of the empty car. Alright, that's just the difference between the total mass capital M and the mass of the four occupants, or 6,720 kilogram minus 250 kilogram. And we will get the mass of the car equal to 5,470 kilogram in three significant figures. Finally, we can now find the period of oscillation, capital T, of the empty car. Alright, capital T is just equal to 2 pi multiplied by the square root of the mass of the car, that's empty, alright, included in the radical sign, alright, you still have to divide the mass of the car by the force constant K. So substituting, we get 2 pi times the square root of the mass of the empty car, 5,470 kilogram, divided by the force constant K, 6.13 raised to the fourth power kilogram per second squared. So, doing our math, we will get the value for the period of oscillation of the empty car, which is equal to 1.88 seconds in 3 significant figures. Alright, so what does this mean? A persistent oscillation with a period of about 1.0 second makes for a very unpleasant ride. And we know that the purpose of shock absorbers is to make such oscillations die out. So indeed, the worn out shock absorber used by the car in this situation badly needs a replacement. So that concludes our tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.